Hey everyone, welcome to another episode on the Geek Nighter podcast. I am your host Kaivalya Apte, and today I am joined by Jacopo and Ciro from Bauplan. And as usual, like we go into deep internals of a certain technology, certain product, we are going to do that with Bauplan and understand what specific problem does it solve, how does it change your architecture, how does it solve the problem, what is the architecture like, and what's the future. So Bauplan is a serverless data platform which aims to make it easier for you developers to build data pipelines, probably easier in terms of developer experience. But we'll hear from both the founders and understand how it all works. So welcome. I'm really excited to have you both, and let's get started with a little bit of introduction about yourself, about history of Bauplan. How did you come up with that, and what specific problems were you trying to solve? Maybe start with Jacopo.
Sure. First of all, thanks, KV, for having us. It's an honor, a pleasure to be here. I think there's a long list of friends that have preceded us in this podcast, so it's good to be here at last. Chira and I built a company in San Francisco. It was called Tuzo in 2017. And it was doing NLP and AI when it was still hard to do it, and there was no API to solve all your problems. And then we sold the company, and we were leading AI and MLOps at the acquiring company from growth to IPO. So we brought the company public, and then we left to build Bauplan. Why we're telling you this in the first place? And the reason is that because while we like fancy NLP and AI stuff, like, just like the next guy, we both have a PhD. We come from, from that background. We publish extensively in information retrieval, personalization, all of that. It turns out that 99% of our time we spend it wrangling data across the several variation of that. Data lakes first, and then warehouses and whatever. And 1% of the time we spend building the actual model. So when it was time to build a second company together, we thought that we should solve the bigger problem first, which is, preparing the data, versioning the data, get the data into a good state, and leave model later, instead of doing what we did with our first company. I guess, the youth errors in the youth. So that's how we came across the idea of Bauplan in the first place. We are the first user of Bauplan, in the sense that Bauplan is a system that we wanted to exist when we were building data pipelines and ML pipelines and data science project ourselves. And now we're trying to bring that knowledge into the world with a complete different set of ergonomics than any existing platform whatsoever. Like, Ciro, did I forget any?
Yeah, also, like, AI changed so much to 97.7% of what we did in the first company, like today, would not work at all, or we would do like completely different. Yeah. But yeah, I think like the general point is the data platform has been the bottleneck for us one way or another, like in several ways. We went through, a number of different, I think, incarnations of different kind of like technological cycles. We did like our fair share of Spark, and then we did, some more warehousey, modern data lake, modern data stack kind of thing. So we had like different ways of doing this, but like it was always somehow lacking a number of abstractions to make it like very simple. My problem personally was kind of like a technical problem that became like more of a management problem very quickly. The big deal for me was we were building a team, and so we had a bunch of different people coming and joining, and like the long ramp up for developers was a very big problem to solve. Like, how long does it take for your developer to learn this new platform? If it takes like 8 months, it's not good. And hiring, retaining talent, like a lot of that boils down ultimately to developer experience, I believe, which is a hard concept to grasp. Sometimes it's a hard concept to measure to a certain extent. So like management sometimes have a hard problem, a hard time like figuring out exactly why this is so important. But ultimately in your business, that becomes a problem of, oh, I need 15 people instead of 5, and I don't know how to hire them, and I don't know how to retain them, and so on. So Bottleneck is really an effort in making things as simple as possible, but not simpler.
Okay. Fair enough. And you mentioned some of the the bottlenecks that you faced and some challenges. What are some examples of these challenges? Like you mentioned about improving developer experience and the simplicity in building
Yeah.
these data pipelines. What were other problems that you think existed?
I think that the general problem that we had was a situation that I think is fairly common, where you basically have a certain distinction between where people work when they develop
Hmm.
and where people work when they deploy.
Hmm.
And these two worlds are very different, as the people are different, the tools are different, and you have like this process of bringing things to production that becomes cumbersome. And so we basically had, Spark stuff to do our job, and then you work on notebooks. You tend to have like processes that are not super well suited to be a software application. One thing that I think is worth mentioning is that a lot of data science, I think, historically has been internal use cases, but that's not the world we were living in. So when we built data stacks, it was always because we were doing some machine learning applications that ultimately was serving the customer somewhere. So it was a search engine, and we were providing the search engine to a customer, and that search engine was out there in the world serving results to a person who's purchasing something on an e-commerce, for instance, right? Or a recommender system and so on. And so when you have this need of having your application to be part of a larger application, the more you need this to be just like any other software application. And notebooks are always weird in that sense. So like we always had like this thing where like now you have like data science people, they do their thing, and you can schedule a notebook, but it's an n-type pattern. So after a while, some adult will have to walk into the room and actually turn that into production. And that process might take weeks. So it was really, really painful. And I think it's very common. So that at least was, I think, like probably ultimately the main problem. And it boils down, a lot of that boils down to the runtime. It boils down to the fact that you have a notebook somewhere and you have like a Spark cluster, and your production environment is completely different from what you used to develop locally.
Okay. I think I can relate to some of those problems. So I'm not much into data pipelines and stuff, but I did some stuff around data pipelines while I was working at Twilio. I mean, you always do some data pipelines, some data pre-processing, and I can imagine what you're talking about is the fragmented world of how things are done. It's not like a
Yeah.
single pipeline, but it's like, okay, if I want to do this, this is the tool you can use, but then that is not connected with the other tool which I want to use. I don't know, maybe a database. But then at the end, it goes like all into data lake and probably also object storage and stuff like that.
Yeah,
So they're
I
like,
think so.
yeah,
Because especially if you do ML, like like object storage is probably going to be where your data is anyway, and that
right.
like all the stack that grows out of object storage is a bit weird. So you have like just like files, which is a terrible abstraction to work on data, and then you're going to have like some runtime that you have to manage, or some Spark cluster that does the thing. Then you have an orchestrator. Like things happen in different places. And the person who writes the business logic, so the person who writes the pipeline, which is also the person who ideally has the most familiarity with the business problem we're solving, is not the person that has the deepest understanding of the infrastructure environment to make that thing run in production. And so now I have this split between, like the folks that need to make this run and the person that understands why are we querying this data and transforming this data in this way to solve what problem for what client. And a lot gets lost in translation, I guess.
Yeah, I think I can imagine the problem you're talking about, but I would love to take an example here, right? And before I do that, I want you to kind of briefly explain like what exactly is Bauplan, and then we can take an example and probably compare how things would be done if Bauplan didn't exist and how it would simplify my process with Bauplan, right? So what exactly is Bauplan? Let's bring all our viewers to one single understanding.
Jacopo?
Bauplan is serverless functions and Git for data. That's the easiest way to explain it. What does it mean? Serverless function, it means you can write whatever code you want in a function. Function are atomic containerized way for you to express a particular step in a pipeline or in a longer program. How do you combine function? You chain them like you're used to chain function in DAGs on your code all the time. So there's nothing to learn there. And why Git for data? Git for data, we call it Git for data as in data branches. Because a huge problem with data that is not true with software is that data, the input in data when you work with a program, may be tens of millions, hundreds of millions of rows. It's not like a unit test when you have like a tiny JSON when you test your payload with your web service. And so what people do, they have the terrible idea of having development data environment, which are things with fake data that don't represent in any way the real distribution, the real data. You have to sync them all the time. You're going to create way more bugs just trying to develop in that compared to that. But of course, you don't want to touch production data. Why this has happened? Because you don't want to touch production data directly when you develop on you debug or whatever. The solution to this is let's do whatever we were doing with code. So we do data branches in the same sense that we do code branches. You develop your data on production sources, a sandbox from the actual environment. And then people can develop safely knowing that if the results replicate, that is production. This will actually work. And goes back to Ciro's initial thing of like, before Bauplan or outside of Bauplan, there's always the questions. How do we bring this to production? Like, will it work when it's not on my computer? And the solution to the it works on my computer problem that I'm sure KV you're very familiar with is it never work on your computer in the first place.
And there is no your computer. Exactly.
Yeah, that's
Bauplan.
No Bauplan is, yeah, Bauplan is functions are always in the cloud, data is always in production. You're always in production. So if you remember the Facebook thing, was move fast and break things. This is move fast and don't break things. Work directly in production, no complexity, but make sure you don't break anybody's code or downstream dependencies by that. So that's the essence of it. And then of course it's a fractal, then it ramifies in, a lot more complexity in APIs. And I'm sure we're going to go through this in the rest of the episode, but that's what it really boils down to.
Okay. That's interesting. And the problem or the approach about just creating a branch like you would do with your code, I think it's really powerful. Even with databases, like some Postgres compliant databases, I guess Neon does it. Mm-hmm. They give you like this ability to just switch branches, and it's really powerful because oftentimes I faced this problem like also a few days ago that okay, there is a query that I'm running on my database and it's extremely slow. But then I try to explain, do something, try to understand. And I want like real database to test that if my query is going to be better, right? But I don't get it. Or I get like a smaller version or a different version of that data in some other environment, which is nowhere close to production, right? And if I get that, I can be really quick in solving these problems. And, as you said, like you're doing something on production. It's similar to that, but you're not breaking things, right? That's the major difference. And I can also imagine this problem in the data world. I think the understanding of what Bauplan is clear, but I want to get into some details, right? So let's take an example. For example, we are recording this podcast and I have, recorded hundreds of different podcasts. So let's take this example. So I have my video files, I have my transcriptions, and, somewhere, let's say on S3 or some object storage. And what I want to do is I want to process everything, like all video formats and also the transcriptions, and kind of also join them, do some cleanup in terms of, removing filler words or removing silences, or I don't know, some audio fixing, all automated, right? And I publish this podcast also on YouTube. I want to also create some interesting shorts and stuff like that, and, produce it on YouTube Shorts. Also send audio only to Spotify or something like that. And also, let's say, produce it to a vector search engine where people can just type and search what's being talked about in the episodes, right? This is the use case. We don't have to cover everything. I just try to draw the picture. Without Bauplan, how would typically a developer do this?
I mean, depends on the level of sophistication you want to do, but let's say you want to get a good level of reliability and robustness to this. The first thing you need to do is that you need to have a way to make your transcript and metadata about your episode XYZ with Ciro and Jacopo was recorded in March, whatever. And you need to pair that with the raw transcript or raw data that you want. And to do that, if you want to stay in object storage, you need to have open format. So you need to pick an open format, and you need a data catalog that supports it. And then, of course, it's on you to develop all of this to do that. And that's step one for the data. Then step two, if you want to version your data, that really depends on what you mean by version. If you want to do it per table, you need to build abstractions over the open format that you picked to be able to do that. If you need to do multi-table transaction, that's more complex. And again, you may want to roll your own solution or trying to fork some open source stuff. And then you need to add the compute. Adding a compute means you need to run your own cluster of Kubernetes, Spark, Lambdas, depending what you want, Fargate or what you need to do. And you need to connect these two things, which is a lot of work. So for example, you need to connect your Kubernetes cluster or your pods or your Lambdas with your open formats. You need to make sure that the data goes into these functions and move across the functions in the proper way. And by doing that, you need to make sure that you can replicate this if something goes wrong. You need to build the containers to make sure that all the functions are different. So to be very, very practical, some of our customers used to do this, different use cases, but this process, stitching together no less than 6 AWS products. Okay. So now you need to learn, deploy, stitch together 6 AWS products. When there's a bug, God help me finding which part of CloudWatch now that print statement is printed somehow. And now I do connect all of this. That thing is out of the window. And now they use Bauplan. And then Bauplan somehow fulfill the entire use cases, end to end. And you need to learn 3 APIs instead of 7 AWS tools.
Yeah, I think the simplification of the infra is certainly a big point from an architectural standpoint, but is the simplification of the developer experience, I think that is what impacts the most the final user in our case. Ultimately, what we're kind of saying here is you can think of your data layer in the simplest way possible. It's just an S3 bucket. And you can think of your compute model in the simplest way possible. It's just a function. So you can just run it anywhere. You want to do a pipeline, you're going to just stitch functions together. So the design principle of the platform is, if a straight out of school computer science graduate does not know a concept, that concept should have a strong justification to be in your platform. And when you apply that kind of principle, you kind of you boil down to the fundamentals. And fundamentals are, not everybody knows what a Spark cluster is, but everybody understands what a function is, right? Not everybody knows what a container is, or even if they do, that does not mean that they understand how to use EKS. But everybody knows how to add, a package. And so we allow you to declare that in your code. You don't know what Parquet or a data lake or a Hive table or a Heisberg table or but you know what a table is in a more abstract way. It's just columns and rows and filters. So why don't we allow you to declaratively just feed those tables as an input in your function and so on? It's really about, this should take an hour to figure out at most. And most data platforms are fairly weird, I would say. Yeah.
Absolutely. I can imagine. I mean, first of all, it's overwhelming to just know that there are so many platforms and which one should I use. Are they compatible? Are they costlier than each other? And there's just so much decision making to do even before starting this process, right? And that's the major friction I have faced. Instead, if I just have to write a few functions and chain them together, which is my mental model, by the way, right? I'm exactly thinking
on your
about
data, which is the biggest blocker for you to adopt a new data platform is, oh God, I have to migrate into that. Right. But if you keep your data on S3, write a couple of functions on that. If you like it, keep it. If you don't like it, just unplug it. The data is still on your S3.
Right. And I mean, it's the feedback loop is so quick. And right on my data. It's not just test data that I have to synthesize or something, right? And that's really powerful. So what I get from this is that it actually gives you a simple mental model because, as you said, everyone understands what a table is. Everyone knows what a function is, and they know what they want to do in terms of functions, right? And then they can change this function, create a complex data pipeline, but they don't have to think about the infra, the operational problems, the failures. How do I connect this to my data and stuff like that, right?
Yeah, I think like the difference between Bauplan and any other kind of like function as a service platform out there, because there's a new generation of function as a service that really kind of push this idea that your way of working in the cloud should be more streamlined at AWS, and we definitely appreciate that. But like the main difference, I think, is that this function as a service runtime is built specifically for this use case where you build data intensive pipelines. And so your kind of like atomic function when you think about your program is not only a function, but is a function that is already integrated with your S3. And so instead of dumping just random file in your S3, it will have this nice integration with a table and this possibility of versioning your data and doing all the branches. So like the kind of like the vision of the platform is the thing you need to learn at the minimal. The minimal thing you need to learn is very simple. Is a function integrated with a table, with a bunch of tables in S3. What you can build out of that once you add that kind of like multi-dimensional layer of branches can become insanely complicated. Some of our customers use the platform today to basically get rid of entire medallion architectures. Like there's a huge part of their stack that is about maintaining 3 different data environments for data, raw data and semi-prepared data, and actually business tables that are business ready. Like all that just like disappears, and it becomes branches and processes that you can at that point program better, which is another point that is like super important. A lot of the things that happen in data kind of reinvent concepts that already exist in software engineering, but in a way that now is kind of hard to integrate in my CI/CD. It's kind of hard to like, now I have this part of my infrastructure that is different from anything else. So the vision here is you can do insanely complex things. Like our biggest client uses, the platform to do write, audit, publish patterns, which is again, it's kind of like it's a data specific version of what in software has been established like for decades, but using this very simple abstraction. So you like from this atomic simplicity, it's like a fractal. You can create like something very complex and very robust.
Right.
That was always the vision, is like, what's the simplest thing that I can give you to build something that is extremely robust?
And I think that's what developers love, right? Because they want to build like complex stuff, but the friction to enter that world should be really minimal because they want to try things quickly and test things quickly. So I like the idea. Let's try to understand with this example, right? Let's say I have a few functions and I want to chain them together. So first of all, can I make these functions reusable? For example, like I create a bunch of functions that work on my data in S3. And then I also want like some other team that can use my function, just changing the parameters like where to read the data from. And it's like your libraries that I can make. So my pipelines are basically in a form of like chain of functions, which I can export as a library and people can use it. And again, it's simple for them because that's a black box for them, and they can work on top of it and create even complex data pipelines, right?
Yeah, you can achieve this in 2 ways. So the only thing that changes parameters, we support that's called Bauplan parameters. That are even parameters in clear. Like let's say you have a pipeline, a typical in the real world, the parameter is going to be almost always the date. Yeah. Because pipeline runs on start date and end date.
Right.
Okay. And then you can basically reuse the same code passing different parameters or runtime or secrets. We support secrets. So sometimes you want to pass an OpenAI key. Yeah. So we pass a cryptographically, like a private public encrypted secret, so that you're like peace of mind. Nobody's gonna is going to see that. That's going to be just decrypted in the function. But I think a slightly more interesting thing is you want to build your own set of functionalities in your data as a Python package you deploy to your own AWS private pip, for example, or whatever things you do. Bauplan will allow you to call that internal package and install it in any function in your team, which means that every function you now have abstracted away some of this for your team. And then every Bauplan function can just pip install basically behind the scene that library that is private to you, to AWS, and then you can use it there. And it's a very powerful way as opposed to copy and paste the same thing between 33 notebooks in EMR, which is, I know you're laughing, but this is actually, the life of most people before this, right? So
I'm laughing because I've seen it, right?
I mean, you have no idea what I've seen. So but it was like, Bauplan is way more similar to reusability, testability, and all of that in normal software, with some few adaptation to data that of course are very powerful because they makes that data aware. But at the end of the day, any software person will immediately catch it as, oh yeah, I think I understand how it works.
Sounds good. Whenever I'm writing like these functions, right, and there is always this talk about when it comes to clean code and stuff like that, your functions should not be longer than these many lines and whatever. I mean, it depends a lot on context, but specifically in this context, right, like a function is a more complicated thing in the backend, right? And I will get to that, like what exactly function means in Bauplan and what it does in the background. But is there some recommendation? So when I'm thinking at this abstraction where I'm creating these smaller functions, nothing really stops me from writing everything in one function, right? And then it becomes like, the same problem. Like, I have this huge script.
That's going to stop you to be a bad coder. Yes.
Yeah, there's a catch to it though, right? There's a catch is Bauplan functions are mapping from one or more tables you should get as input. Tables can be views, can be generated by other part of the functions, or can be persisted somewhere in S3 again. The platform does it for you. But then every function need to output a table, okay, or a data frame, or like something that looks like a table, which means that typically you're very discouraged by doing everything into a 2000 lines of function, because that will restrict your ability to basically persist assets. Okay. So the platform automatically allows you, as actually invites you to split function at least by, let's say, responsibility. So if this function is responsible to generate this table or this RAG or whatever application, it should be its own function because it's reusable, it's containerized, and because it's going to be what is going to actually be written back into the data lake. So while nobody's going to stop you, from sucking in the great scheme of things,
right?
The platform sort of invites you to at least have isomorphism between functions and asset that gets materialized in a sense.
Yeah,
there are a couple of things here because, like, if you think of the SQL world, so if you think of like more kind of like transformations for analytics or things like that, so that type of paradigm that ended up like being more popular with tools like DBT kind of created a world where we gained. I mean, there are problems there as well, but like at least like we got rid of those 2,000 lines of SQL kind of queries where if something goes wrong, it's very hard to debug. So I think like the equivalent of that in the data science and machine learning world is a notebook, which is literally kind of a black box. It's kind of like a small monolith that now runs somewhere, with the additional problem that there's also the problem that the notebook has states. So there's also complication in making sure that it actually runs in the way you think it's going to run, right? But generally speaking, the division of labor remains: I run the function for you, I containerize the function, and I move the data for you. So I get the data from S3, I expose the data in a format that is declaratively a table. I pass the data around from one function to another, which is incidentally the reason why we had to build this runtime almost from scratch, and we couldn't reuse function as a service, existing function as a service tools and frameworks. You write your code inside of a function, so there's a limit to, like, there's, of course, like you can if you write the same function in pandas or polars, that is going to perform differently, right? But ultimately, you trade off a little bit of generality for simplicity, and also because we run Python, I cannot really have a query optimizer here, right? Like there's infinite things you can do. But we should try to approximate that as much as possible, because if the framework is built for you to specifically do data pipelines and data jobs and not just like general Python as in everything, again, like I cannot guarantee the same strictness that I have with SQL, but there are a lot of things that I can do at runtime in terms of optimization now that I also have complete visibility on the data layer, right? For instance, in a Bauplan function, you're going to import a table, which means that you often are going to do an S3 scan directly in Python. So can I do something there that is better than just like read the data as they are all the time? Can I do smart caching? There's a lot of things that I can do once I introduce some limitation in your at least in your templating of a pipeline.
Interesting. I'm now pumped to actually talk about the internals of Bauplan, like how things work, right? Like from a developer perspective, I understand that okay, the mental model is simple. I have to just think about like functions, like small transformations, and probably create my functions based on responsibility, like what exactly I want to do, and take input as tables, produce output tables, work with real data, and all of that. So that is simple. That is good. Let's say I want to take an example, like a very trimmed down example. For example, I'm taking a video. I'm just, or let's say even not even a video. I'm taking a transcript file. I'm just cleaning it up, giving it to, let's say, OpenAI or something, and creating a summary and publishing on my blog, for example, right? This is a simple to understand pipeline. I want to write simple functions. What happens? So let's say I create a function to read the transcript and clean it up in the sense remove pauses and filler words and produce it output, right? So when I write this function in Bauplan, what exactly happens? What is Bauplan doing in the background?
I can guide you through the step of what happens. So you write the function, is in your IDE, is in your local computer, and you have installed Bauplan. You have an IP key to use Bauplan for your organization. So that's the only requirement. Okay. So it means that before you put your transcript in, an S3 somewhere, and you make sure that Bauplan sees that. We can go through detail of that. It's a trivial, but I just assume that there's a table somehow called transcripts with all the transcripts, just to simplify that.
Yeah.
You're gonna write your logic. You're going to put a decorator on top of your function that tells Bauplan that you need OpenAI package or whatever package you need. Then you're going to open your IDE. You're going to go into the folder in which the file is. Then you're going to do Bauplan run. And you're going to press enter. What happens now is that your code gets packaged and gets shipped to our control plane, which is the multi-tenant part of our architecture. When the first part, we call it the planning, happens. So of course we authenticate into a bunch of trivial stuff that we need to do. But what happens after is that we take your code in Python and you parse it out. Parse it out to understand how many functions we need to run. What is the proper degree of parallelization of the platform? Is this a DAG? Are you referencing a table that doesn't exist? So we block you immediately. We don't want to do, if you're familiar with DBT, that used to happen like a lot with DBT, that you find out your errors at the when you run the 99 table instead of immediately. So Bauplan will try to do a lot of static checks to make sure that everything is fine. And then we're going to produce what we call the physical plan, okay, which is very analogous to what happens with a database. And we do that using Kuso, which is, I'm sure, you remember Semi was here before us. So we use Kuso. We can go into the detail of how we do that. But the idea is that we build a graph out of your functions, and then we use Cypher to make a bunch of inference to basically extend this graph to an actual plan that is detailed enough to be executed. That plan gets sent to protobuf to the runners. Runners are off-the-shelf virtual machine, EC2s, which are single tenant, is the only thing that sees your data, and are connected to your S3 bucket through a specific YAML role, and if you want, with private link. That EC2s contain our proprietary binary, the Bauplan runtime, which will receive the plan, which tells you which function to execute, which package do we need, where is the data, blah, blah, blah. And it will execute them, with some scheduling logic, and it will stream back the result through a bidirectional connection to your CLI. So the feeling that you get in all of this process is that you get a print statement basically every few seconds on your terminal, like it was running locally, but none of this runs locally. But again, you don't have to go on CloudWatch, wait 5 minutes and search that. Everything that happens in your function is available directly into your computer immediately. So this is the higher level, system, how it works. Does it make sense?
Yeah, I think it does. So just to validate my understanding, because there are
Sure.
many details you just talked about it at a high level, but so I write a function and let's say I use the Bauplan annotations and then I say Bauplan run, assuming I have the Bauplan installed. It kind of packages my Python code. Then validation happens if there is some validation errors, like the table does not exist or there's some problem. It will give me an error message immediately. Otherwise, it just basically a tenant gets an EC2 instance where exactly the plan is created, the tag is created. You use KuzuDB to kind of create this tag and create a plan, and then it goes and executes some Bauplan program or software, and that exactly runs and executes the program. And then the good part is that it streams the output back to me on my CLI and gives me a feeling that it's all run locally. So I think, did I miss something? Did I misunderstand something?
That is a perfect, let's say at the higher level understanding, that is perfect. And then again, this is a fractal. So each of these thing components that you can imagine branched out, and we can go dive deeper into, each single system and the optimization that it makes. That is a mental model of what happens when you do Bauplan run. Right. This is exactly what actually happens.
Okay, that's perfect. So we are probably at a very high level. So mental model itself is a good thing to have. Let's go deeper a bit, right? Like when I write my, let's say Python code, right? Like, okay, basic validation is fine, but then what happens? Like, how do you understand the DAGs? Where is it stored? And why Kuzu? And let's talk a bit about that.
So we parse out your Python code or SQL code using. So for SQL, we have our own kind of custom parser for reasons we can go into that, but they're not very interesting. For Python, we parse out using just normal Python, and then we built out the Kuzo ephemeral graph in memory, and then we run for each request basically the inference that we need to run. Why Kuzo? When we started, it was just normal Python code. But if you think about a graph, think about a 10 nodes pipeline, each of which has 3 packages as a function, each of which has different tables going in and out. Each of which has columns and all of that, even answering a simple question like, does this column exist in all the parents? Is kind of like a cumbersome Python recursion that you need to write. It's going to be slow as fuck, and it's going to be very error prone. And every time I need to add a new check, I need to add another one of this recursion. So what we said at some point was like, scratch that. This is a graph. Why don't I just run inferences on graph? And so I start searching for something that was like a fast, embeddable graph databases. And the only one on the market
is literally the only one who's out
Kuzo.
there.
We started very, very early. Kuzo was not, was very, very in its early days. And so I think we were the first, among the first paying customers, like definitely one of the people that uses the most. So we helped the team and they helped us understanding better our use cases. And so what happens now is that this temporary graph gets built in, few milliseconds in memory. And now the concept of validating a graph property is not a cumbersome Python recursion. It's a cipher query
inference
that you can do as a graph inference, and it's going to run on C++ on all the cores on our machine, and it's going to be much more declarative and much better to read as a graph path than what it would be a Python code that now requires a lot of debugging. So that was the reason behind Kuzo. But so that's part number one. Like, it's still planning. Now we need to plan the containers. Like, how was the containers built? And let's say you specify pandas. Okay. What we do is we actually do the transitive dependence. So we figure out that pandas, you need pandas, but also you figure out that pandas depends on other, 25 packages, right? Yep. Depending on the version of pandas that you pin. Okay. And so the system is responsible for doing this full traversal of the pip dependencies. And this will become a big part of your physical plan. Okay. So when this gets sent to the actual runner, the runner now doesn't just know pandas, pandas and the 23 things that need to be installed. And then it does a neat trick, which is why our containers start builds in hundreds of milliseconds. So most people working in the same team will use most of the same packages, which means you can use a clever cache and reuse most of these packages across different function invocation. Okay. Furthermore, even if you specify different versions of pandas, me and Ciro, we're going to have some transitive dependencies that are the same, which means, again, you don't have to reinstall all of them. So there's a lot of reusage, even if you change the higher level package. So the cache leverage this, kind of trick we call team locality, in analogy with space and time locality for CPU. We call it team locality. The idea that people works on many of the same packages, which gets you for most users like an extraordinarily, easy and fast experience, while still building Docker containers that are fully Docker compliant and can be orchestrated as Docker containers with all the other things, like with gvisor if you want to do and all of that. So we kind of get the best of both worlds. Super fast builds, but still kind of like the interface and the package still looks like a Docker container. So that's another big thing that happens in that sense. And then the final thing, again, we're going kind of like one level deeper than before, then we can give them both Docker. It's like your function is rarely the only function that gets executed. So in Python, since Bauplan is declarative, your tables, which you declare as, hey, I want table, what's like transcriptions. I want transcriptions and I want them from yesterday to, from last month to this month. Okay. As Ciro was saying, this is a declarative approach. But what happens is that the system will transfer this to a specific function. We call them system function, which is function that you don't see as a user, but that runs by translating this high-level definition, our transcript from May, to, hey, I need this freaking file, on these freaking columns, and this corresponds to this byte scan. And this works across branches, across point in time, and all of that, right? And so that's the system function. So when the system actually runs, even when you run one function with 2 lines, it's typically few functions. The function that you don't see, and they're used by the system to make sure that the data that you need is there for the function to run. Your own function, containerized and built as I explained. And then, possibly, other function downstream if you need to write back. When you write back the results of your asset, again, you don't really write it in Bauplan. You just say, please write it for me with a decorator. And that corresponds to another function that gets added at the end of your DAG automatically for you, whose responsibility is to write this. So the final thing is always a DAG, even when you write one function, because the system needs to juggle other stuff that are declarative in that sense. And what does this buy us? This buy a very important thing, which is our entire runtime is just because of a very hard problem, scheduling functions. Like everything, including our own operation into the lake, are just functions, which means our runtime is very uniform and we think fairly elegant. Everything is a freaking function, even the function you don't see. This works even with Bauplan query, which is kind of the extreme version of this. But we can go into that, into that later.
You see, like as I was saying, is this awareness of your data? And now you can kind of like explode this modularly and do like optimization if you want, in a way that is, it's impossible to have it in the same exact way you would do with a runtime in a database, but you should try to approximate data as much as possible, because ultimately the kind of like the user experience problem that we need to solve here is I don't want you to feel that your cloud experience is either too different or too slow for you to develop directly against the cloud. Because I think there's a lot of value for organizations and enterprises to have all their developers to actually execute their code against the cloud all the time. You get scalability, you get generalization, you get reproducibility, you get determinism, you get a lot of things that matter a lot to an organization. But the reason why I'm going to fall back to my laptop is mostly because either my cloud environment is like, I don't understand this. I don't even know exactly what's in this, but I need a simpler mental model. So I'm going to work on my laptop. Or it's just slow. And it goes like, I can't wait 3 hours to change like one line of Python because I have to rerun this in Airflow. It's just, I can't do that. So I'm going to do my own thing on my laptop. So to prevent that, you want your runtime to be fast. And the bottleneck is always like the two bottlenecks when you run pipelines are always the same. Is to a minor extent, your container. You don't want the container to take minutes. You want the container to take milliseconds. But to a major extent is your data. Like even if your container is instantaneous, if we go to S3 in a dumb way all the time, you pay a price that is going to dwarf every other optimization you can do on your runtime.
Mm-hmm. Interesting. I think, yeah, again, it's simple, but a lot of complexity is hidden, right? And, even the annotations that I add are, processed and, probably creating some DAG nodes and stuff like that. You mentioned about the caching part, and it's really interesting, and that's a good point, right? Because as a team, you're probably working with the same code. You're just changing a few functions here and there. But at the end, if you look at the entire dependency graph, it's probably has a lot of common things, and it makes sense to cache it. Where exactly is it cached though? So you mentioned that when you create your, let's say, the physical plan, you understand what is a dependency and you use the cache. Is it just like an in-memory cache on my EC2, or where is it happening?
Is in the runner. So there's a fair distinction. So your codes get parsed out in the logical plan, that gets supplemented with all this information for the physical plan. Let's say the full PEEP, transitive graph and blah blah blah. That can be done only looking at metadata. That's why that is a control plane that never see your data. But then that gets shipped to the EC2s that gets assigned to run this, and the EC2 will have a local view of what has been run before. So it will have its own cache on disk and memory for both data and packages. We can discuss data part. Data part is like slightly subtler, of course. And then depending on what is already in the cache, it will decide to not download Pandas 2.2, but use the one that it has versus to download that. So the final decision will pertain to the EC2s. So it means that the same physical plan may actually require different action depending on the state of the EC2s, if you already run it or not. But the plan will be the same. The decision the Bauplan lives by is buckets, like things that are important are in S3. In your S3, the customer S3, EC2s can be wiped out at any second and nothing tragic will happen. It's not going to be fun. Okay, you may need to rerun some stuff, but nothing will happen if EC2s have no cache, more cache, less cache, they destroy the cache, and so on, because functions are ephemeral compute over S3.
Yeah.
And since writes are atomic and transactional because of we data catalog and branches again, blah, 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 your pipeline either completes or it doesn't. There's no intermediate states. And if everything happens in between, again, maybe you need to rerun stuff, but things are never left in a bad state. It's a huge guarantee for our customers, especially because an early startup, if something goes wrong, nothing really goes wrong forever.
Okay.
Everything can always be recovered. Nothing ever is dirty in the lake, in a sense.
Yeah. As a matter of fact, there's a fair amount of stuff that actually the platform does to guarantee that when things make it easy for you to retrieve those states that correspond to a failed state, essentially. Because, because data pipelines fail fairly often, and they fail for reasons that are not necessarily clear immediately. And because data is essentially a shifting system, which I think is the biggest difference between just developing on data and just doing software development, is that, if I have to reproduce a pipeline, now I kind of have to be sure that I have the same environment in a runtime, the same data and the same code. And I have 3 things that now I have to check in 3 different places. And so there's a fair amount of the stuff that the platform does automatically. Like, for instance, when you run a job and it fails, that's going to create automatically a reference branch. So it's hey, this is a branch where you can find the version of the code and the version of the data of when things went wrong. now you can check out into that and like work with that branch like immediately. Because like I think like ultimately the robustness that you want to achieve here is a combination of making your access point to all these different things as simple as possible, but most importantly, making it programmable. Because like you want to automate these things. You don't want to send your data engineer on a chase on a bunch of dashboards. You want this to be a program.
Yeah.
And so it's one API, it's one ID, it's one ref branch. Like there are ways to programmatically tell you things went wrong. Here's the code, here's the data, here's the environment. Go there, replicate this, debug, and come back with a better solution. We actually it was kind of it was a bit of a kind of like a sci-fi moment, but like something like 10 days ago, we were just like presenting this at an event from the MLOps community, and we're just like playing around with the concept that because this is so simple and so programmatic, you know who else is really good at doing this? AI. So I can actually send an agent a commit and say, hey, here's a pipeline that failed. Here's the code. Here's the data. And here's the environment. Rewrite it and fix it. Run it again and let me know how it works. And if it works, you merge it. And if it doesn't, I don't know, call the cops or something. But like you can actually, there's a layer of automation that I think 3 years ago was just impossible to believe it existed, that now opens up with the kind of like agentic wave of AI. And we designed, like the platform is already designed to talk to an agent because ultimately it's just code.
Yeah. Interesting. When we talk about branches, right? Like let's say I'm working on, I don't know, I have a pipeline, right? And I want to add something to the existing pipeline. So usually like how I would do in a code is like I create a branch and I work and test it, and then probably someone would review and then merge it, right? So I want to understand the workflow there. So I'm working with a new branch. I write a new function, probably change my DAG, and I want to make sure that everything is correct. So first question is, can I write some assertions within my code to tell that, okay, this means failure, this means success?
Yes.
And what other failures will it kind of showcase where it says, okay, something went wrong and this is the branch, this is the data? So is it just about the user-defined failure states, or there are some other states that Bauplan says, okay, this is a failure?
Yeah. So there are there are a number of things, like, so there's certainly the things you can program in your functions, and that's all right, that's your code. There are some data quality built-in tests, as in more like an expectation like. So they usually are just like built-in functions that we provide out of the platform that map a table to a Boolean. And so if something goes wrong there, you're gonna just like have your, you can decide whether that is just a warning or an assertion, or we can run that test in a vectorized manner very fast for you. And then there's a bunch of checks that the platform does on the kind of like form of compliance here, what you're trying to do, as Jacopo was mentioning before. Like an example there would be, like this table doesn't exist, or there's something wrong in the input that you're trying to, or in the output that you're trying to return. In that case, I don't even run. I don't even try. Like I know that this doesn't have the right shape and of a DAG, and so there's no need for me to bother the runner and occupy resources.
Like when you if you think about this as part of a team, you would do that by, hey, I create a branch manually because I'm developing. You add a function to your code, which will materialize a new DAG or whatever.
Yeah.
You run it, and then you can say to your colleagues, let's say if there's an error, there's an assertion error, whatever, you're gonna get an error, so you're gonna iterate on that. But when you're happy, what do you do? And you can do exactly as you said. You can ask a colleague to take a look and say, hey, my code is on branch KV demo today, or whatever transcript today, and they will be able to check out that, run queries on that. Again, Bauplan, we haven't gone through, but Bauplan allows you also interactive exploration, so you can throw a Bauplan SQL query to Bauplan, and Bauplan will respond immediately without building a pipeline, which is very handy for quick checks on data and small dashboards. And then you can, when you're happy, you can just merge in a way that is very, very similar to the code.
Yeah.
And if you want to do that on a batch automation, you can do that by using the Python SDK. So you can program the branch creation, the running, And you can say, hey, I get back a result. If result is correct, merge and delete. If result is not correct, send a Slack alert. So you always have these two planes of like Bauplan as I write the DAG when I develop. And then you have the meta layer, which is the Bauplan client, which is how can I direct the platform programmatically when I get back typed object that I can inspect with code and make sure that that object actually works. You have both things.
The users kind of like, depending on where you are in your journey from, an experiment to production, you're going to interact with the platform using either the CLI or the SDK. So we spent like a lot of time, like a significant investment in making this as kind of like uniform as possible. So when you iterate through a CLI just because it's snappy and it's the way for you to do things. So you create a branch, you run it like probably you run it in memory. So you just check stuff, you run a query and so on. When it's the time for you to merge that, what our clients typically do is they script using a Python SDK all the logic that they want to script into their CI/CD process. That typically looks like either a script or a bunch of GitHub actions, or sometimes it's just like somewhere in your orchestration logic. So it becomes like an Airflow task or prefect task, stuff like that.
Okay.
But you can always interact CLI and Python. Like you always have these two ways of thinking because they correspond to two different moments in your development, right?
Yeah.
Is when a person is in front of the screen, CLI. When a machine runs this, SDK.
Yeah. Interesting. Cool. How does the scaling work here? For example, I'm writing a function. Sometimes depending on the data, that may require less resources. Sometimes it may require more resources. How does Bauplan understands? Of course, it will understand the data, but what happens? What kind of resources are given, and how is it done? Based on which stage and when is it done and stuff like that.
So right now this will be in charge of the runner. So again, because before we actually see the data, we can't really know how much data we are getting from S3. There's an argument to be made that we could be more details in cardinality estimation even at a higher level, but right now the system doesn't do that. So the system deferred the decision of how big the containers are to either the user. There's a way for the user to specify how big a function needs to be. Nobody uses that. You could do that, but nobody uses that.
Yeah.
Or the other one is to leave the system basically optimistically starting to, with some amount and then kind of get you more as you need it up until like an upper bound that is set depending on the type of instance that you use. Bauplan comes in size like t-shirts that are basically priced in different capacity that you can basically process. And so there's a limit depending on your t-shirt size. There's going to be a limit that the system will enforce, and at that point it will refuse basically to run a job that is bigger than that. The scalability. So people mean different things with scalability. One is, if there's more data, will the function scale up different than Lambda? Yes, the function scale up immediate. Like you don't have to do like a Lambda to redeploy everything with different configuration. Those are liquid. Sometimes the C group of a container gets actually updated in due course. So that's totally fine. Does it scale as in can you have pipeline with hundreds of nodes? Totally possible. The system will either schedule them in the same runner or multiple runner depending on what happens. Can multiple people work on that? Yes. That's a big point about Bauplan is that multiple people should be able to use the same capacity, exploiting a curious fact that, for example, people at Google have been known for a while, like the Borg paper, if you're familiar with that, which is even production systems are rarely 100% at capacity. Actually, they're almost never 100% of capacity. And there's a lot of spare things that happens. And Bauplan is built for you to save money on that. So instead of having 3 pipelines, each of which is a Spark cluster, each of which use the worker 30%, we invite you to send us your function and the platform will impact them for maximum efficiency. So that's the only scalability thing which you're going to hit in this design is all our functions as of now are single node, meaning that you can run whatever you want in a function. It may be very big. Some of them are hundreds of gigabytes because of the runners that may be very powerful, but we're not going to parallelize the work for you. The system will take a function and will run it as a function. that's it.
Yeah, for now. Yeah.
Interesting.
I think like we never like really hit that, like that was never like a big issue, honestly.
Yeah,
Like
it's very
most
rare.
workloads
Yeah.
out there tend to be like very reasonable scale. Like they tend to be like in the order of magnitude of gigabytes and terabytes. Like even in very large companies, like our largest client is very large. Is a large company, makes like more than $3 billion. So B2C. So there's a lot of data there, and but the average workload tends to be like at most terabyte, in the
Interesting.
terabyte scale. That
Okay.
kind of like matches also my previous experience before Bauplan. We worked with a lot of enterprises, and I think like there's a lot of data sitting in the lake.
Yeah.
But that's not necessarily translates into, I don't know if that's your experience as well, but like it hardly translates into massive workloads.
Yeah.
Most
think-
remember most DAGs are always partitioned by like at the end of the day.
They tend to
the data comes, data is like grows like entropy goes in the direction of the arrow of time. So every day there's new data in the lake that you want to import and you want to transform, but that's the marginal thing that the orchestrator will tell you to run.
Yeah.
And that's the unit of compute that you need at the end of the day. At the end of the day, you always process one day at a time, 1 hour at a time, 5 minutes at a time, whatever that is. But in most cases, it's very rare that one day or 1 hour of data for your batch will be more than 100 gigabytes.
Yeah.
So the problem actually doesn't really materialize itself for the vast majority of time.
Yeah.
But as you know, it seems we're nerd that we're discussing system. That's the trade-off that we've been making, right?
Yeah, there's a certain point where it makes sense for you to get Spark.
Yeah.
Very simple way to execute most of things.
Yeah.
So we're building for the bulk of use cases, but there's going to be the outlier that may require a specialized knowledge, and that's not this Bauplan that we know today. We know in 3 years, but it's not about. So that's the trade-off. As engineers, it's like good to be honest with things that you're good at and things that is not part of your operational envelope, and that's the choices that we've been making so far.
Okay, I think that's fair enough, right? And I actually wanted to ask this question, like, what is the use case where Bauplan wouldn't be the best fit, right? Probably this is the answer.
Gigantic, massive workload of an exabyte.
Right.
Definitely not the right one.
Yeah. Okay.
Or SQL or interactive SQL queries that are very big as well, right? So you can run SQL queries in Bauplan very proficiently because of this concept of asynchronous and asynchronous that get been packing. So it's free. Like it's not like Snowflake. Not going to be built every time you run. But if you're running ad hoc exploration on 2 petabytes of data, Bauplan is not the query engine that you need.
You should get Snowflake and call it a day.
Okay, interesting. This is good. I have 2 more questions. Around testing part, like I'm writing my functions, right? And I want to test them and on regular basis. For example, whenever someone makes changes, I want to ensure that they're not breaking the existing pipeline. But these are still not regular functions, right? These have a lot of things happening in the background, probably hidden from the developer. How do I write tests? Can I assume in my mental model that these are, again, simple Python functions? And on what data does the test run? Is it running on, let's say, a different branch of my original data, or I have to create, let's say, some synthetic data to do that?
They test 2 types. So you can test 2 things with data, and one we call them expectations, and one we call them unit tests. What is the difference between 2? Expectations are things that are like you expect your real data to conform to.
Yeah.
And these tests cannot run statically. They always run when you run the actual pipeline. A good thing about Bauplan compared to other systems like dbt run and dbt test, for example, is that tests are run directly when you actually have the buffer in memory. So you don't have to wait for this to materialize to realize that you're wrong. And actually, the data doesn't even get copied because if you use one of our tests, we use arrow in between all the functions. So expectation gets co-scheduled, co-located with their main parent functions. And even if you run 100 of them, the data is 0 copied available to all of them. So you actually incentivize to run a lot of expectation because they're free for the system to use and they're very fast. And this will basically answer this question. Does my data, as it is in this particular branch in this run, conform to some expectation like no null or median equal under 5. So that's one of them. Fully supported by the platform. There's a special decorator. The platform is built to you to do this. And then there's a different concept of test, which is irrespectively of the data that exists in my lake, what would happen if this function get as input this data that I just made up as an edge case?
Right.
Will it still produce the right thing? And these are called unit tests. And unit tests, which are in beta right now, but there are syntactic sugar for you to express mock data and expected output,
right,
and to pass a Bauplan functions inside. So that doesn't run on your branches or on your real data. That runs on your mock data and will check your logic. It doesn't check your data. So data needs to support two compared to software, and we support two to support both with different kind of like syntactic sugar. But these are two definitely valid concerns that you may have. And then of course, if you have your own software that you import as a library, you can test it, with outside, and you can just import it and do that, depending on when you put the logic. But we support all of this.
Right. I think that makes sense. The other question I had was about, so I'm creating these branches, right? Like whenever I work on something new, I want to test something, I'm creating this branch, right? And this branch can actually mean a lot of data. And when I do this over a period of time, there is definitely bloated data that I'm probably paying for, I don't need. So how does that cleanup happen? Does Bauplan have a way for me to say that, okay, whenever this branch is, let's say, merged, clean up the data, or does it happen automatically?
There's a few things there. When you do a normal merge, in this normal as in the sense of like I'm building a pipeline, a new version of the pipeline, and I'm running, and I'm happy, and these should be the new tables that I see in main. The merge will just automatically swap the tables into main. And so the old tables will stay there, but the new tables will basically just, get the pointer, get basically promoted to main, but nothing ever gets copied twice. So in the style of S3, everything is immutable. So the old files will still be there, but the new files are not going to be there twice. They're just going to be there as in their branch, but now the catalog record them on main. So that's sorry for the pun. That's a common way for this to work. There's a other aspect which I sort of related to merge, but most related to the concept of data lakes are just piles of immutable files across time, which is your general state of your lake. And we provide some compaction for that to happen. You are free to, if you want to expose the full underlying manifest of the tables. So if you want to delete files after a while, you can get them programmatically from the system, and you tell S3 to delete it or then move them to other storage. However, mind you, if you remove an immutable file that has been referenced in a table in the history of our lake, you don't get the full reproducibility guarantee that Bauplan offers you as of today. Because as of today, if you never remove files, you can go back 1 year from now to a Bauplan instance with the ID of a specific run. You don't even need the code. You just need the ID of a run. And you can do Bauplan rerun ID, and that will run with the same code that ran a year ago on the same exact state of the data 1 year ago, and you're guaranteed is going to get the same result. But if you delete the file,
there's nothing you can do.
I can guarantee that.
There's nothing you can do. But that has been like particularly beneficial to our client when it comes like to compliance and debugging. So there's like this kind of like mixed bag of needs. Like some of them are like more development oriented, something breaks and it's hard to replicate. But others are just like more on the compliance side. So certain industries or GDPR like requires you to keep data in a certain state for a longer term.
Yeah.
And it's been like very, very useful for our clients to use this functionality of time travel in along like 3 dimensions in just like one comment.
Yeah. I've been there once when I was working in, let's say, the billing industry. And I had to look back at 6 months ago, there was a bill and it looked incorrect and they reported after 6 months. So I had to go and debug, and it was a nightmare because I didn't have the exact code. I didn't have the deployment. It took a long time just to look at, okay, what were the commits we made and stuff like that. What was the report we generated? And the data was also there, but still, not really accessible in an easier manner. So it would be amazing to just, kind of write some commands and run and understand output, and probably also compare with the new run.
That's as of today is like one of the main users of the platform. Like as of today, this is actually what people can do like with one single API call.
Right.
The other thing is like when time goes by and you might want to save some S3, some money on your S3 bill, like that stuff tends to go on Glacier. Well, like the good thing of that is that it's a bit more laborious, but it's like it's trade-off between like how much money you want to pay and like how keep being compliant. You can always re-import that, right? And like you can always rerun it because like the reproducibility and determinism are two main characteristics of this platform. Replayability comes hand in hand. So worst case scenario, sure, it's going to be a little bit more work. You're going to have to redo it over again. Fine, but you can. Like it's not lost forever.
Yeah. It's still less work than an engineer or two working on something that is not reproducible and understanding, 6 months old.
Oh no, that is that is just like following the white rabbit down in the hole for like days. And the worst thing of that is that when you come out with an explanation, it's not really clear whether, it's like, I believe this is what happened, but I'm not really, like, I cannot really ensure that. So in my experience, to be frank with you, people just rerun stuff.
Right.
And if it works, it's just like, it works now, I guess. So like, it's not a super, like my experience with reproducing problems with data pipelines, especially in analytics and data science, it's not exactly a science. It's more like people are pretty much winging it.
Interesting. Where are the runs saved though? So when I give you the ID that, hey, run this ID, where is that stored?
So there's a meta. So in the control plane, we have RDS. So it's a Postgres instance, just to be very practical.
Yeah.
That stores the pointers to the code, which is saved on S3 as a snapshot. And it saves some additional stuff like who ran what parameter was passed. Remember the example of the dates. What was the logical plan that got produced by Code Intelligence? Code Intelligence is our model that parse out and do the CUSO stuff and all of that. So once you basically do Bauplan run by ID, the system is able to go back in time and know what was your code, what was the plan, and then know the exact commit on your data lake that correspond to that specific date. What was the exact state of your tables at that point? And then they basically inject that in the functions. Again, that you don't see, but the system injected in the function for you. And then, you're off to the races. Then you have the data, you have the code. You just need to run this again on whatever branch. And you get the exact state of the system as of the day that it was there. Which is good because now you have two branches, the main branch and the debug branch.
Yeah.
And they're both coexist. And you can point your visualization tool to, for example, one or the other with a drop-down menu to see, hey, can I visually immediately see with an histogram or whatever what that looks like?
Yeah.
Or you can point your downstream system to these two things like, hey, can you train a model with these data sets, or can you train a model with this data set, and then you verify the correctness at the end. And all of that is sort of like supported nicely by this branching idea and the fact that everything is one parameter away from you.
Okay, that's really powerful actually. When I think about the problem I faced, I think I could have solved it quickly. But anyways, the only thing you wouldn't have is the cache, right? Like the cache that you maintain for this.
Exactly. Yeah. Of course. Yeah. Exactly. There's no guarantee that 1 year from now you still the same packages and the cache. Right. Of course, there's no guarantee. That's an ephemeral thing, but it doesn't. By definition, a cache doesn't affect correctness, right?
Right.
The result is going to be the same. It's just going to be probably slower than what you originally wrote.
Right. And as long as I'm using, let's say, my dependencies with proper versioning and stuff like that, you can again re-download all the old dependencies as well. And it should be deterministic.
All of that it should be pending errors in either side, but this should be is built to be fully reproducible.
Remember that most of those things at this point like are declared in the code. So like a lot of that is like there's somehow like a more general intuition on that, like outside of the you have to reconcile these 3 dimensions to be really fully reproducible, but like the runtime data and code. But there's a lot of simplification you can achieve if you buy into the concept that ultimately the code is really the operational part of it. So it's the code that is going to generate the table, and it's the code in this case that generates an environment. So if I have that version of the code, I will be able to give you the same container, and I will be able to give you the same table. This is the code is the generative part of it.
Okay.
While the other way around is impossible. Like I cannot reconstruct the code from a table. I cannot reconstruct the code from an environment. Right?
Interesting. Cool. What's there that you're working on? What's there, currently missing in Bauplan that you're planning to release? If you can share that.
So on the engineering side, I'm going to let you discuss use cases later. But like on the engineering side, we are working, to improve a few things in the platform that we believe are very peculiar, but will make users even more happy to use it. Branches are one of our core features right now, and people are very happy with it. Mm-hmm. But there's a bit of work to be done to make them, snappier, quicker, to make the merge, more Git-like in that particular sense. So we're gonna kick off some of that soon. So expect some innovations in that particular sense. And we have a bunch of papers on more researchy idea of like, things, looking a bit over the horizon on memory management that will come out, hopefully in the next few months. That has been done with a few top tier universities. As you can imagine, memory management is a big part of this scheduling function. Like even after we reduce the entire problem of scheduling function, sure, it's very elegant. There's one thing to solve, but this thing is very hard. Yeah. And memory is the most contentious of all resources because of obvious reasons. Is the harder one to scale in, within a machine. So we've done a lot of work into what true zero copy system actually means, and would be super happy to share it soon. So this is on the engineering side. And Ciro, what do you think on the use cases side?
On the use cases side, I think like right now, like the problem that we solve is very clear for any organization that has data science or machine learning or AI engineers who are kind of like graduating towards software. So really the value proposition is making things much, much easier and faster for people to pick up. But like from an organization point of view, you can think of this as kind of like bi-directional. So it's very clear today for us that there is data science people who need to be more software engineering oriented. That's a clear move in the market. There's a clear kind of like push in the market right now. There's a lot of people doing, especially on the LLM use case or RAG use case. So like use cases that tend to be consumer, like user facing. So things that ultimately need to be an application and not just an internal use case. So that's a very clear pull for us. I'm particularly interested, I think, in some more sporadic patterns that we see in the market now. But I'm a good believer of the fact that these two things are going to converge, which is the other way around. That is software people who are kind of like starting to do more data stuff. And again, there's a lot of that comes from the simplification that, especially in machine learning, happened thanks to pre-trained models. So all the quirky thing that I and Jacopo and I needed to know at the time to actually do this like from scratch, it is simplified by the fact that now I can call a pre-trained model because like there's incredible inferential capabilities that are like captured by basically an API call, right? So I see more and more like software people kind of like getting dragged into data. The first push is honestly clearer for us, like in terms of market. Data science people who are basically kind of like, okay, this notebook thing is cute, but we kind of need something. We need something more reliable than that. That's our client today. But I start seeing also some DevOps and software engineering people going like, well, can I use AI as well? And just like have a way to think about this in a more principled way and more programmable. And those are, I think like that's a very interesting direction developing in the future.
Yeah. I was actually about to ask you that, since you're making kind of working with data a lot easier, because you don't have to think about like 10 different things, 10 different tools, even to solve a simple problem, you just should know how to write Python code, for example, and how to think about functions and, you know your data, and that's all. So I think that makes it easier for software engineers who are, used to write a lot of code and, test their code and work with branches and work with data. I think they can easily move and work on the data side. They don't really need to know a ton of tools and different platforms.
Yeah, I think like today we see that mostly in the contract between the DevOps and the data science. So like when the moment comes, you have to bring things to production. The fact that the platform is built around abstractions that every developer knows really helps this translation problem that otherwise the data science or the machine learning team often has with the platform or DevOps team. But generally speaking, I think like the haha moment for us was when the first junior engineer that came on board and in the company and one of our clients, and I don't think she ever saw a S3 bucket before. Like, like completely foreign to the concept that AWS is going to ruin your life.
Yeah.
And then she's just like, come there and like run, like, hacks around with the platform for like a couple of weeks. And then she just like puts in production a large pipeline that does like near real-time analytics for a major product. That was really the moment when we're just like, oh, this can actually work. Because as a manager in my previous life, the fact that I can now hire a person straight out of school and expect this person to be productive in 2 weeks, not productive as in like can write code, like productive as in can push stuff to production reliably.
Yeah.
That would have been amazing. It would have cut like so much effort on my end. It was just like recruiting, retaining, all the work around like forming a resource from in 8 months from now, this person that changes his job. And I literally wasted 8 months of my budget creating forming a developer that now goes like, sorry, I don't like Scala. So it's like, I can't. First of all, I can relate. I cannot really blame you. Secondly, all right, that's a shame. So that was really like the really powerful thing. It's like you have a developer, they can work.
Amazing. Well, we have covered a lot of ground, and in the interest of time, I think that this scope is good. We'll probably talk about future innovations in another episode whenever we are ready. But yeah, I love the discussion. I'm more than pumped to get my hands dirty with Bauplan. I'm going to do that. Probably I'll just try the transcription, whatever example I took. That's an interesting one. But yeah, I love the discussion. I love the product. I love the problem it is trying to solve because it's so developer oriented. So yeah, thanks for coming and sharing all the insights. And I'll for our viewers, I'll make sure I add the links to the papers you have written, and also some of the YouTube videos where you're showing the examples like how to create these pipelines and so on. But if there is anything I can add more, please definitely share the link so I can add it. And people who haven't watched the Kuzu episode, because Bauplan is using Kuzu, I did an episode with Semi, and that's an interesting one. So I'll also attach a link to that so you all can watch it. But yeah, thanks a lot. I love the discussion and looking forward to releasing it soon.
Thank you for having us. This has been a pleasure. And yes, please, as I always say, come and break my product. Like, try it out, find some bug. Like, yeah, get your hands dirty. We would love to have you on the platform and try it out.
Awesome.
Thanks again.